The title of this lesson is Geometry. It's for semester 2. It's the second unit, which is called Special Right Triangles, and it's the second lesson in the second unit called 30-60-90 Op Leg Practice. This is found on creatormath.com under the Geometry tab. Follow this title, look for that unit, and match up, especially this 30-60-90 Op Leg will match up the video with the lesson you have to do in Schoology. So the instructions are copy the following problems. This one says 1 through 8, it should say right here. So copy the following problems 1 through 8 into your composition book on the correct pages according to the table of contents with the notes for those pages. Don't forget the notes, you guys. They explain a lot more about this content than just these practice problems. These practice problems are what you do after you copy the notes into the comp book. And of course, it's on creatormath.com under the Geometry tab. They explain to us triangles with words, given a right triangle. So that explains to me something. With one angle 30 degrees, that explains something to me, right? So I know if one's 30 and one's 90, the other has to be 60. And the reason the other has to be 60 is because the three angles of a triangle have to sum to 180 degrees. I'm going to draw my triangles, if I can, pretty much the same way every time. I'm going to make it a right triangle, and they told me that right here. It's a right triangle, so I have a square down in one of the corners that says that angle or vertex is exactly 90 degrees. Then it tells me there's a 30-degree angle, and that's a smaller angle here. And if this is 30 and that's 90, this has got to be 60 here. So this is the famous 30-60-90 triangle. That's what the whole lesson is named after. This is called, it's one of the two special right triangles. The other is the 45-45-90. But this one's focusing on this, and this is focusing on the op leg. All right, so one of the things we need is we need the pattern. And again, this is in the notes for this lesson. Given a 30-60-90, we have an x, 2x, and x radical 3. And that's what teachers love so much about these 30-60-90 triangles. The pattern of the sides play out every single time. If you tell me no matter how big or small the triangle is, if the angles are 30, 60, and 90, I'm going to know that the one across from the 30 is x, the hypotenuse is 2x, and the leg adjacent to the 30 is x times the square root of 3. So let's continue here. The side length across from the 30 degrees is 10. So we go across from 30, which is opposite in geometry, and we label this one 10. Okay. Then they say to us, what is the length of the side across from the 90? So they want this one over here. So let's put a question mark. This is the hypotenuse. It's the longest side and across from the longest angle. This one is a leg, and this one is a leg. A triangle has two legs like a human, and the legs are attached or touching the largest angle. In this case, it's the 90. So what we have to do is match up what we've been given. We've been given a 10. That matches up with the x. All we need to do is say x equals 10. We place them equal to each other because they are corresponding sides. And once we know that x is 10, and we know that this side up here is 2x, all we need to know is 2 times x is 20. The length of this hypotenuse is going to be 20. And that's what's so cool about these triangles. I don't need to plug in cosine, sine, and tangent or any of the trig functions. I can go straight to the ratios. Let's try another one. Number 2. Given a right triangle with one angle 30 degrees. So I'm going to try to stick to my same pattern here. 30 degrees, right triangle, 60 degrees. This is a right triangle. There's 30 degrees. The side across from the 30-degree angle is 10. What is the length of the other leg connected to the 90-degree angle? So this looks very similar. They say the length of the side across from the 30, across means opposite here, is 10. So this is 10 long. But this one changes it. This one asks me up here, what was the hypotenuse? This one's asking me, what is the length of the other leg connected? That's this one right here. The other leg connected here. They're asking me this side now. Well, once again, the 10 matches up with the model for this 30-60-90. The 10 is x, so we say x equals 10. Then we know that this side down here corresponds to x times the square root of 3, And if x is 10, then literally this side is going to be 10 times the square root of 3. That's how long this side has to be, or 10 radical 3. Radical is another name for square root. And just to show students, they always ask me, what is this square root of 3 thing, right? Let's go to, you have a calculator on your phone. Make sure to turn this thing sideways, right, to get the trig calculator. And then let's just clear this out. Let's say square root of 3. What is square root of 3? If we take the square root symbol 3, it's 1.73205080076, etc. It keeps going on and on. It's an irrational number. Well, instead of saying 1.732, blah, 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 we can simply say square root of 3 and leave it in that format, and it's more accurate. Now, we can multiply a number by it. So let's say we multiplied this by 10 times this. Oops, come on. Let's do this. Here's a 10. So 10 times this ends up being 17.32. So this side is 17.32 long. We're not going to say that. We're going to leave it 10 square root of 3. It's more accurate. It doesn't truncate all those digits right here. All of them are inside of this definition of square root of 3. Okay, there's some background. I won't explain it every time, and I'll move a little bit quicker here. Let's go down to the next. Given a right triangle with one 60-degree angle, and these are all 30, 60, 90s, the side across from the 60 is 30. What is the length of the side? Okay, so let's draw it. Here's a right triangle. I'm going to keep it in the same orientation, but I'm going to read what they say. So I got a right triangle. It's got a 60-degree angle and a 30. It's got to. The side length across from the 60. So if this one's 60, the side length across is 30 long. What is the length of the side across from the 30? They want to know what's this one over here. Well, this one's probably the most complicated side to get because this side matches up with the x times the square root of 3. So what do? We take x times the square root of 3 and we place it equal to the value they gave us, 30. We divide both sides by square root of 3 because I'm trying to isolate the x. Square root of 3 over square root of 3 is 1. I'm not allowed to have a square root in the denominator. Please see the notes on how to rationalize the denominator. I'm going to multiply this by square root of 3 over square root of 3, which is multiplying by 1. Anything over itself is 1. You can multiply anything by 1, and it does not change the value. You multiply $10 times 1, you still have $10, right? So this is not changed. It just changes the way it looks. So this equals 30 square root of 3 across the top. This equals square root of 3 times square root of 3 is square root of 9, which simplifies to a 3. With a 30 on the top and a 3 on the bottom, that becomes 10. So this becomes 10 square root of 3. That's this thing simplified. And what we did was rationalize the denominator. You are not allowed, we are not allowed in math to have a square root in the denominator. So we must rationalize this process. So this is what x is equal to. If x is equal to this and they want to know this side, and this side is x by definition of our 30, 60, 90 ratios, then all we need to know that this side is 10 times the square root of 3. So we're going to come over here and say 10 radical 3, and radical is another word for square root. So 10 times the square root of 3, or 10 radical 3. Given the right triangle with 1, let's set up the same thing. And these are very repetitive. So while they're extremely difficult at first, if you can get the hang of it, it starts to become like, oh man, I've seen this a lot before. All right, so given a right triangle with one 60-degree angle, I've got a right triangle, I got a 60. The side length across from the 60, that's this one, is 21. What is the length of the other two sides? They want to know both this one and this one. It doesn't matter. We're going to take this 21 and put it equal to our model, which says on that side it's got to be equal to the x times the square root of 3. So we have x squared root of 3 equals this length 21. We divide both sides by square root of 3. This should look very familiar. We rationalize by multiplying by square root of 3 over square root of 3. The reason we chose square root of 3s is because this denominator is square root of 3. If it were square root of 2, for example, we would have multiplied it by square root of 2 over square root of 2. Cancels from here. 21 square root of 3 here. Square root of 3 times square root of 3 is square root of 9. This equals 21 square root of 3 over 3, because square root of 9 is 3. 21 divided by 3 is 7. So we have x equals 7 square root of 3. That's the length of x. So that's got to be this one here, because this one's x. This one's 2x, according to our model, right? X, and this one's 2x. Well, 2 times 7 square root of 3 is 14 square root of 3. So notice we have a 7 radical 3. That's this one. And we have a 14 radical 3. Aww. And two answers. The one side, they don't distinguish which side is which. But this side here is the 7 radical 3. This side here is the 14 radical 3. This is the first one of the problems where they actually drew one for us. For the following triangle, what is the value of CB? They want to know this linked over here. And I would do as I like to do. I'm going to take this and just rotate the whole thing back to the way we had it, right? This was 90, so it rotates to there. This was 60, so it rotates to here. That makes this 30. So now we're right back to our model. And the model to me of the ratios, just to draw it again, if this is 30 and this is 90, then you have x, 2x, and x radical 3. And that should start to look familiar. That's the pattern we use every single time with a 30, 60, 90. And notice it's very specific. The x is across from the 30. The hypotenuse is the 2x. And the adjacent leg to the 30 is the x squared of 3. So they're asking us this side here. Let's put a question mark here. They're telling us the hypotenuse is 12 long. And now we know that 12 is the hypotenuse. We're going to match that up with its ratio, which is 2x. And we're going to say 2x equals 12. Divide by 2, divide by 2. X equals 6. If x equals 6 and this side is x, then this side is 6. So done. And notice how much simpler it was when they gave us the hypotenuse rather than when they gave us the side matching up with the x radical 3. In the prior problems, that was a lot more difficult algebra. We did not have to rationalize any denominator here. We didn't have a square root in the denominator. All right, let's go to this one. Given a 30, 60, 90 special right triangle, what is the measure of the side length across from the 30? So now they're literally asking me about the model. 30 degrees. Try to clean this up a little, make it look like a triangle. Across from the 30, we know the model's x. It is every time. Done. All they're doing is asking us about this model. We already drew it. We know what the side across from the 30 is. All right, it's x. We know what the hypotenuse is. It's 2x. And we know what the leg adjacent to the 30 is. It's x radical 3 every single time. That's the beauty of it. That's why us geometry teachers are so wigged out by it. Because we can't believe that this consistency is true with a triangle, right? It's supposed to be a random universe. This is not random. Okay, 30, 60, 90, special right triangle. What is the measure of the side length across from the 60? Let's make this 30, just like our model. Let's make this 60. This is x, 2x, and this is x radical 3. Across from the 60, which is what they ask right there, is x times the square root of 3, or x radical 3. This one seems to be asking me all about the model. So given the next 30, 60, 90 triangle, what is the measure of the side length across from the 90? Let's just use the same diagram here. Just go across from the 90. It's 2x, you guys. It's the model. It's the same every time. So 2x. So this is the real key right here. And this is in the notes and explained a little bit better. But, you know, just to explain it, it becomes a definition of 30, 60, 90 is special because these ratios play out every time in these locations, right? Across from the 30's x, across from the 60's x radical 3, and the hypotenuse 2x. No matter how long this side is, this side could be 100 long or 5 long, these same ratios to each other play out every single time. So you're on creatormath.com, you're under the geometry tab, and this is from the special right triangle unit.